of teachers, let them know that we've gone live, and right now we already have our speaker who is ready to be with us. So if you're wondering where this is coming from, so this is from the stables of A Plus Educators community. This is a community for educators, and what we do is we look for different ways, we explore interesting tools, technology that can be used to make learning and teaching better in the classroom. Today is a big focus on math. We know how math can be very abstract, how math can be very difficult, but we're going to have someone that is here to let us know the interesting way we can really learn math, and especially for every teacher in your network. Let them join. And some people will say, "Oh, I'm not teaching math, or I don't want to do this." But it's very important that you also learn different interactive ways that you can use technology in your class. So welcome once again to our G Teach series. And like I said, what we do is different ways to make tasks, make topics interesting, to make it relatable using technology. And today's tool, once again, is GeoGebra. I'm so excited because I'm one person that did not enjoy math in my learn this. Maybe something I can teach my kids later on, or it's something I can share with other teachers, and it's something I'm really looking forward to. So before we introduce our speaker, we're going to start 7 on the dot. It's 4 minutes to go, so take our time to let us know where you're joining us from in the chat box. Let us know where you're joining us from in the chat. Where are you joining us from? I'm so happy to see everyone here. Thank you so much, Hilaire. Thank you so much, Irene. Thank you so much, Raymond. Thank you so much, Oscar. Thank you. And kindly put in the chat box where you're joining us from. Quickly, so let us know. Hi. Hello, Oscar from Mombasa. It's so good to meet you. I would really love to learn how to say hello in Mombasa. Hi, Hilaire from Lome. Bonjour. Bonsoir, Miss No. Thank you so much for joining. And so want to also know where Raymond. Hi, thank you very much for joining. Thank you so much. Irene, I hope you're here. And please also put it in the group chat. Let people know that you're here. You know we have started, and every one of us need to be here because we are here to learn a lot. We're here to really make sure that we're learning 21st century skills that keeps us very relevant in this age and time. Because if you don't know how to use technology, I don't know what you're doing, sincerely. So it's a good thing. And I'm so happy that our speaker also, our guest facilitator, is here and is ready for us. I've seen a bit of what he has for us, and trust me, it's awesome. It's something I cannot really wait for to see at this time. So I'm going to just quickly play a video. After the video, we're going to get started. Thank you, everyone. Okay. Three, two, one, rock. Level up, 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 level up. Tell me so yummy, but it sounds so yummy. But you want this yummy? Level up, 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 level up. Tell me so yummy, sounds so yummy. All this yummy, yummy, all your time. The mistakes are gone.
I won't do them no more. There's no news, there's news. I done did that before. I turn nothing into something. My comeback on 100. Let's talk it, more action. You just go see coming. I just keep elevating. No losses, just upgrading. My lessons made blessings. I turn that into money. They gotta never settle. This view is so much better. I'm chilling, I'm winning, like on another level. It's all on the wall. Yes, praying, nothing else praying. It's making it all.
Detail, current statements of the technology.
3, 2, 5, 4, 3, 2, 1. Level up, 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 level up. Oh, the so yummy. Oh, the so yummy. No, you want just yummy. I mean, all your time. Level up, 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 level up.
Tell me with the other channel,
So yummy, so yummy.
television there.
Yummy, all your time. Them moments they song.
You may just download the channel.
There's news. I done did that before. I turn nothing into
And last,
something. My comeback on 100. Let's talk it, more action. You just go see coming. I just keep elevating. No losses, just upgrading. My lessons made blessings. I turn that into money. They gotta never settle. This view is so much better. I'm chilling, I'm winning, like on another level. It's all on the wall. Yes, I'm praying, nothing else praying.
it's charging.
4, 3, 2, 1. Level up, level up, level up,
It's
level up,
charging.
level up.
Okay, so thank you so much. Just a reminder that every one of us should level up, and level up means you need to ensure that you are using technology and you're using it effectively in your classroom. Thank you so much also for joining. As you join us, let us know where you're joining us from. It's very important because it helps us to know what you're doing. It helps us to know you're appreciating what you're doing. Thank you, Irene from Tanzania. Um, Karibu Tanzania, I guess that is our being said. So thank you so much also for being part of this. Thank you so much, Francie, for Burkina. Bonjour, merci de. Thank you so much for joining us. Also, thank you. And I'm also very happy that you're able to be part of this. You can share the link to join with your friends, with your family, with your colleagues, with everyone. Let them know that we have started. And it's also very important that they start with us because this is going to be as practical as possible. So as you keep on joining, let us know where you're joining us from. Today we have our speaker, and wow. So our speaker is Mr. Agwamo. He's a Nigerian, and he's also I must call him a math guru. I got to know about him from a lot of things that he was doing on YouTube, and that was how I got to know what the kind of works that he's been doing and the kind of impact he has been making in the math field using technology. So this person is a math teacher at every point in time, and what he really focuses on is trying to looking at mechanisms and different topics that can be very difficult for students, and looking at how to make it easy for students using technology. So it's not just using tech because he saw the tool somewhere. It's something that he has done over time, and is going to be sharing one from experience. He's going to be sharing expertise, is going to be sharing this because it's something that he has done over and over again. He has gotten good results, and we must say it's a privilege to have him here to be able to share this with us at this particular point in time. Thank you, Moses, for joining from Lagos. Thank you for joining us. And without wasting much of our time, because we don't really have so much time and we want to achieve so much within a little time, I'm going to be opening the floor for Mr. Agbamu. Thank you so much for joining. And I would really appreciate if you can call your full name. I'm so curious to know what the full name sounds like. Thank you so much for joining us, and the floor is open to you. Thank you.
Thank you very much. Can you all hear me? Good evening, everyone.
Good evening. We can
Evening,
hear
sir.
you. Yeah, we can. Sure.
Okay. We are all welcome. My name as Bishop, before I will start, I will say thank you very much to the organizer for giving me this opportunity to talk to educators, these wonderful educators, as like all of us present here. So I'm so happy for this moment. Thank God for everything. At least knowledge is important. It's good when we have it, we share, we learn, and we pass it to our students in class as well. All right, so my full name is Agbamu Idonogrene Amudo. I know when you see the name online, sometimes you say, "Ah, what kind of long name is this?" But that is my name from Nigeria, from Delta State in Nigeria. So that is that. Just as Mrs. Light have said, I'm a mathematics teacher. I've taught maths for many years, and I love using technology to teach in classroom because I've experienced so many challenges those days when these tools were not available. You want to teach, but children have issues. You have this thing in you, but you don't know how to pass it to these children. But with technology, you can make some of these things easy, and your students will follow you very well. All right, so let's go straight to the presentation so that we'll not waste much time. Okay, I think I can share my screen.
Yes, you can share your screen. Thank you.
All right. Okay, let me. Okay, so I think everyone can see the screen.
Yes, we can. Yes, we can.
All right. Okay, so this is the topic, developing problem-solving skills using GeoGebra. So as you can see my name over there, Agbamu Idonogrene Amudo from the DG Teach series. All right, let's go straight. Okay, so today's presentation, I want to focus on these objectives. So I want to look at how we can understand the role of problem solving in mathematics and how we can exploit GeoGebra tools for interactive learning. So when we say GeoGebra tools, just because of the time frame of this presentation, there is no way we can utilize all these tools. But I will try to pick up some few GeoGebra tools, some applets that we and choose some topics so that we can get and choose some topics so that we can understand GeoGebra tools very well. Then we should be able to demonstrate classroom-ready GeoGebra activities, then share practical strategies for technology integration. All right, let's move on. So why is problem solving matters? So why do we need to solve problems? So without wasting time, I just pick up some 4 points here to encourage critical thinking. You know, this is very important when it comes to teaching, especially in mathematics. Critical thinking is a major thing we need to encourage our students to have so that we help them to think even outside the box, think about real life situations and try to solve most of the problems in class. Then we should promote deep conceptual understanding. They help students apply mathematics to real life situations, then develop creativity and reasoning skill. Okay, let's go straight. So this is where our work will begin now. Now, before technology came up, you know, we use our normal traditional way to teach mathematics. Looking at this first point here, abstract concepts are difficult to visualize. And that is one of the reasons most of us hated mathematics when we were in school, because everything looks somewhat abstract to us. If you even ask the teacher, where can I even apply this thing you are teaching me? Some of them, they just use cane and flog us. We don't even know why they are flogging us. So we are just confused. So if this abstract concept, you can make these children see it, let them see mathematics, let them see mathematics moving to bring out some, it will catch up their understanding, it will catch up their interest, they want to learn. So that is one challenge traditional method have, and technology have solved that. And students often memorize procedures, especially those few smart ones, they will just memorize. And that is that. Some of them don't even know why whatever they're memorizing is true or not. They don't even know the reasons, but they just memorize. Then we have limited student interactions and exploration. So students don't really have time to do some kind of exploration, to do some kind of interaction. So they just learn and go. Then the last point I have here is difficulty connecting theories with application. So I created some link here. I have them in most of the slides. Let me just go through this, do some demonstration of abstract concept, how you can make it okay, how can the student visualize some abstract concept. So let me click on this, let's see. Okay, I think we can see the GeoGebra is coming up. We can all see it. Can we see the GeoGebra coming up? Hello, can you hear me?
Yes, so it's still we can hear you, but it's still loading. I think we just have to wait for a while.
All right, so what you are seeing here is an applet. Let me see. Okay. Okay, so this is a GeoGebra applet. So as you can see from this side, you can see the GeoGebra classic name here, the website, like the
Okay, so
software.
sorry, Mr. Abame, would you want to do you want to share what you're showing us, because we are still on your slide. We're not on the GeoGebra now.
Okay. Is it not showing?
Yeah, so
Hmm,
you just need to reshare. Maybe just share your whole entire screen. That will.
let me see. Okay, so, can you see anything?
Okay, so what we are seeing now is what we are seeing now is challenges in traditional math teaching, which is the slide. I'm sure you're opening the GeoGebra app. That is not what we are seeing. So what I would just say, stop sharing. Then after share, yeah, good. So now we share, but just share the entire screen this time around. Thank you so much, Dominic from Nigeria. So while Mr. Bama is trying to sort this, kindly let us know where you're joining us from. And yeah, so also let us know where you're joining us from and what you're looking, yeah, good, forward to learn. I guess we're
I
back.
don't see
Good.
anything.
Yes, we're on the perfect screen now.
See the GeoGebra app, the name on this side where the mouse is rolling. Can you see that?
Yes, we can see that. Good.
Okay, like the last slide, I was talking about teaching in the traditional way. And sometimes this abstract teaching, how can you make the children visualize it? It may be difficult to do that in your normal traditional way. So what I have here is, imagine you are teaching a topic like latitude and longitude. So normal traditional teacher will likely bring orange to the class. That was how I was taught in school then. The teacher will use orange to describe the globe. Those few schools that have the map of the world, the globe, they'll bring it to class, roll it around, show the children the lines of latitude and longitude, which is okay, but having a tool like this, you can make it dynamic. You can make the children see some of those lines you want them to see, because they need to understand all these lines when they want to solve any question on this. For example, you can see this sphere. This is a sphere. Now, let me put those various lines from here. Now, remember, this is an applet. That's one beauty of GeoGebra. We have so many applets. As we move on, I'll show you the website, how you can go to GeoGebra Classic website. It's free to get the app. It's free to download any of the resources. And you can even use the app, improve on yourself on it, and use it in your classroom. Okay, now looking at this, if you look at this place, you will see the polar axis. So by clicking on this checkbox, you can see the polar axis has appeared here, showing the north and the south. I'm just rolling it around. Okay. Now, if I want to show them the equator line, which is the great circle at the middle. So if I click on this, you can see the equator, this green circle. So if I roll it like this, you can see there is a big circle on this sphere. So something like this, when the child is seeing things like this, it sees the way you are manipulating it, they will be curious. That is where the critical thinking starts coming in. You are telling them that equator is the greatest circle around the Earth's surface from the middle. You have the map, the physical remap, showing them using this to do some dynamic manipulation. You see them trying to think. From there, they will start asking questions. So this is for the equator. If I click on this prime meridian, you will see the prime meridian here. So these are the two reference lines, or you can say the circles, and they are both great circles, the prime meridians and the equator. So this is just introductory latitude and longitude. Now, you are teaching them parallel of latitude. If you click on this, you can see so many parallel of latitude, starting from the north. They are getting bigger as they get to the equator. Let me click on this. You can see I've highlighted the parallel of latitude. You can see how they are much. If I roll the screen like this, you can see they are all parallel. No one is touching the other, and they go round. If I roll it like this, you can see all the circles. The one closer to the north, you can see how small it is. As it gets close to the middle, to the equator, you see they are getting bigger and bigger. So with this kind of demonstration, your children will begin to see this as real life situation instead of those abstract picking oranges, taking your marker, going around. Some of them may not really get this stuff because with this app, you'll be able to see inside. You can see the center of the Earth here, represented with this sphere. You can see it here. So let's move on. Now, if I put my meridians, which are the lines that come from the North Pole down to the south, if I click on this, you can see them. You see the parallel of latitude. If I click on this, you will see the prime meridians. You can see them. That is the meridians now. They are all equal to the prime meridian. I'm rolling it around. I can click and roll it around. It's be turning on its own. So there are so many effects you can do in the classroom. Just click and stop it. So with this, your student will begin to think. You are introducing the topic to them, telling them lines of latitude, longitude. You are demonstrating it. Then you create a custom latitude. You see the color have changed to red. You click on this slider. You try to tell them that latitude are lines that runs from the north. You can see the slider is moving. As I keep moving it, it will get to the top, which is 90 degrees. These are the things we do in class. If you want to see the angle, you can click on this. You can see the angle is showing 90. So with this like this, a child, with something like this, a child will begin to think. Some of them will even interrupt you as explaining because you make it interactive. You do a little, you stop, you ask them questions. Some of them will even raise their hand and ask. They will tell you, sir, go back, let's see something. Now, let me go back, let's see. You see, as I'm moving this slider back, you see this is 75-degree north. You can see what is happening. The parallel of latitude now, that is the parallel of latitude, yes, is increasing until it gets to 0 at the equator. So with this, the children, they begin to get the understanding very well. You can go down, when it's 0, it's now equal to the equator. You can go down to south. So things like this, it makes this concept easy for them to understand and to follow. You can do the same with the custom longitude. This is the line that runs from the prime meridian through the east or the west. So if I click on this, if I move towards my left, this is west. You can see how the prime meridian is moving now. That is the meridian line. I is moving towards the east, towards the west. So it will move up to 180 degrees and stop. So you can see it 180 degrees. So that is the greatest angle you can move to the other side. You can put the custom so that they can see the angle. You can see it 180 degrees. You can move it back. See, as it's rolling, they are seeing it. So with this, when you start solving, you start telling them, okay, how do you locate a point? You get the custom latitude. Let's go towards north. You get a custom prime meridian, something like this. You can see, you roll it like this. You can see the angle, this is 60 degrees. The child is actually seeing that the distance between this point and the prime meridian is just an arc. So when you are telling him to use length of an arc formula, he will not be confused. Why are we using length of an arc formula? Because you may not be able to cut the globe in your classroom, do this demonstration. They may not be able to see inside like this, to see the various angles and just like that. So this is one way traditional teaching cannot do when you use technology of this kind. So let's continue with the slide. Let's move on. Let me close this. Okay, so that is one challenge traditional teaching of maths cannot do for you, but with digital tools like GeoGebra, you can solve that. So that is just one of so many you can do. Okay, let's move on. So now this is another one. Let me see. Something is blocking the top of my slide here. Let me see if I can minimize it. Okay, I think this is what is GeoGebra. So this is where most of us, we really want to get it right now, because I've been telling you GeoGebra. I used the app just now, the applet, to do a demonstration of how you can make abstract teaching become visual, become real for your student, and how your student can interact. So now GeoGebra, as you can see, is a free dynamic mathematics software. So it's a software that was discovered by a man in Australia, and it just came out of a project he did in school. So that is one of the brief history. You can go to the site and you can get more information from that. I will give you the site by the end of the presentation where to go and get it. So GeoGebra is a free dynamic mathematics software, and this is what we can do in GeoGebra. You can do geometry, you can do algebra, you can do graphing, statistics, calculus. You can do much, so much. This is just few I mentioned here. Just depend on you, the teacher, depend on what you want to achieve in your class, your objective. Actually do much with GeoGebra. And this is one thing GeoGebra supports much: exploration. The teacher can explore, the student can explore, just like that. You are doing it in class. If you are fortunate to have a system where all the children have their own laptop with them or their computer system, so are doing, they are also watching, they are also doing their own manipulation, asking questions. So mathematics will be easy. They will get it right. So you can visualize, you can also discover as you are learning. So that is one thing about GeoGebra. Let me show you something here. Let me open this. Let's see what's happening here. Sorry for that. The link is not showing up. Okay, let me go straight to where I saved it in my system. Okay. Okay. I think we can see the GeoGebra coming up. Can we see it? Hello, can we see the screen? Hello?
Yes,
Yes,
we can see it.
Yes, we can see it.
It's okay. Now, this is GeoGebra's screen. When you open GeoGebra for the first time, this is what you see. Something is blocking the top of my screen here. Okay, it's out now. Okay. Now, this is how GeoGebra comes up when you open it for the first time. By the time you download it in your system, go to the website, you click on download. I always advise teachers to use the GeoGebra Classic. We have Classic 5 and Classic 6. So this is Classic 6. So that is the one I use more. So this is how it comes up. Most times when students see GeoGebra like this, they are, especially students, they'll say, what is this? They'll say, this is graph paper. What can you do with this? But they don't know that you can actually do much with this. Let me do a simple demonstration with what we can see here. Imagine you are teaching topic like circle geometry. You're in the class, you want to start the topic circle geometry, and you know the student need to know some theorems before they can start solving questions on circle geometry. And the theorems, so we can list them. Let me start with the basic one, which is angle at center is twice angle at the circumference. Now the teacher, traditional teacher will just draw a circle on the board, put a point at the middle, telling them this is the center of the circle. Then from there, let me just be doing it as I'm talking. You see, as I click here, this is circle tools. So let me pick a circle with true point. Let me use this. Depend on the circle you want to do. Just click anywhere on the screen. You can see the circle center A. Just drag. It's looking for the point to end the circle. That is true point. So let me click somewhere here. So that is the circle at the circumference. This is the circumference of the circle. That is B. So this is the center. So let's move so that we can move the circle around. So you can see I can move the circle around. I can click on A, see what is happening, can move it around. So a traditional teacher will just draw this, locate this middle. Okay, let me remove this graph since we are not working with the graph. Just click, right click. You can see grid. Let me hide the grid. Then you can right click. Let's hide the axis so that we work on plane shapes. So everything you are doing in GeoGebra, this view here is the graphics view where you place your images. So you can see the image you are working with. Then this is where, this is the algebra view. Anything you are doing here, the mathematical formulas and the rest will be displayed on this side. So this is the center. If you look at it, you will see the center. It's telling you that the center is from negative 0.88 on x-axis, then on y-axis is 0.74. If I bring back the, let me close this. If I bring back the axis, just right click and the grid, you will see where the point is located. As I'm moving it around, if you are watching here, you will see that they are also moving around. Let me just put it as 0, 0. Then you can also move the B at circumference. Let me just leave it somewhere here. So that is what it is. You can see B, the coordinate for B is +3. You can see 3. That is this. Then for Y is 2. You can see it. So that is that. Let's just close this. Let's close this. Let's remove the grid. All right. So as I said, you are teaching circle geometry. Traditional teacher will just draw this, then tell the student the theorem, then they will start doing the proving. Then most times the children may be confused that how did you know that this angle is equals to this? So to avoid all that, you can actually use tools like this to do some dynamic manipulations. And the children, as you are teaching, you are talking, they are seeing what you are doing. Now I have a circle now. This is the center. As you can see, I can move it around. I can move and increase the radius. You can see. Okay, I can join with a segment, the A and B. I can create another point on the circumference. Let's create somewhere here. Just click on the circumference at this point C. I can join with a segment. In a class of 40 minutes, in 5 to 10 minutes, or let's say 15 minutes in your introductory class, you can do this in the classroom, read time like this in class, plan your lesson where you are teaching, you are demonstrating, and your children, they are following, asking questions. If you observe what is happening here, every line you draw, you can see they are naming it. So this line is named G, this line is named F. If you don't need it, you can just click on it. Just click on show label, it will disappear. That you don't need the label. Just right click, show label, it will go. Okay, now this is the angle at the center. You can see the angle at the center. I can create the angle from here. Let's use this one. I can click the 3 points so that the angle will show at the middle. You can see it's looking for the third point to complete the angle. So this is the angle, and the angle is already named as alpha. You can see the angle is named as alpha, it's written here. If I want only the angle to appear, just right click and move this. No, not this place. If I want only the angle to appear, just click on it, come to this side. You can see some options here. Let me see, something is also blocking this. Let me see if I can remove them. to
Have you
okay.
removed? Okay.
Yes, I've removed it. Yes.
Okay.
Okay, so as you click on this, you come here, you can use only value. I want only the value to show. So now this is the angle at the center. So this is where GeoGebra is very important. I can manipulate this center angle. You can see, I can move it around. As I'm moving it, you are seeing the angle at the center. So if I make it on a straight line, which is 180 degrees, so this is a diameter. Just because of time, I can adjust this, but I don't want to take much of our time. So that is that. So this is the angle at the center. Now, you are teaching your student in class. You want them to see the angle at the circumference. You create another point at the circumference, so which is called point D. Now, point D can also move around the circle. You can see it. Now, immediately you join it with segment now, D to C, then D to B. You can see a theorem has been proven in circle geometry. So this is one of the theorem. Angular center will be 2 times the one at the circumference. And if you want to see the circumference to prove that this angle is correct, you just to come to this place, click on your angle, you click on this and this. So you see the angle is there now. So this is the angle. I don't want the name to appear, just put only the value. So if you multiply 54.22 by 2, you will see it will give you 108.44. So this is the theorem that says the angle at the center is going to be twice the angle at the circumference. So with this, you can manipulate this point D, you can move it around. You see anywhere point D is moving to, you see the angle is not changing. 54.22 is still appearing. So with this, your student may begin to understand something that, okay, irrespective of where this angle D is positioned, because sometimes if you're writing exam, like our external exam, the WAEC exam, they can give you questions like this. Some students may be confused. They say, what theory is this? Because they're expecting the question to come in this format. Because in the textbook, this is how they explain the theorem, this is how they solved it. But WAEC can put it like this. So some students may be confused that what theory is this? So you just tell your student that the theorem still remains the same. The angle at center is twice the one at the circumference. And what is the secret of this theorem? The secret is these 2 points, B and C. If you observe well, you will see that point B and point C, they are like the reference points. So at these 2 points, the angle produced from B and C, they stop at A, which is at the center. As long as the same angle also comes from B and C, it will go to the circumference. So the angle here must twice this. Now look at another theorem again. If I create another point and place it somewhere here, and I take a segment again, connect C to E, connect E back to B, and I put an angle, you will see that the angle will still be 54.22. Something like this. You can see they are all equal. And this is also another theorem in the same topic, circle geometry, that angle in the same segment, as long as the 2 angles, they are on the same side of the circle now, because this line BC, as I said, they are like the 2 reference points. So at this B and C, as long as the angle comes from B and C, which is like the origin of all the angles in this circumference, the angles will continue to be twice the one at the center. So that is the theorem you can see. So with this, you can manipulate it, you can move it around. Students, they can see it, they can ask their questions, you can pause, you can ask them, what if this angle is taken to this other side? What do you think will happen? Let's say I take this other one to this side, something like this. Then you begin to get responses from the student, they begin to answer. Now you can see what is happening. I just move this angle to the opposite side. Now just watch, let me make this angle be on this side. Let it be inside the circle. So all you still need to do, just click on it, come to this side, let's make it 180. So it's now inside now. Okay. Now with this, you can see what is happening now. this angle that was in this side that was 54.22 is now 125.78. So with this, your student, they will just be looking. You can tell them, what do you observe with this? Can you discover something from it? You are trying to help in their critical thinking now from the introduction to circle geometry. They are just watching what you are doing. You move this point D. The angle is not changing. It remains the same as long as it's on this side of the circle. You move this angle, it still remains 125.78. They are seeing it. You say, what can you observe? So that is their critical thinking is being checked now. They are looking at it. Then from there, you discover that if you add these angles at the circumference, these opposite angles, 54.22, if you add it to 125.78, you will see that it will give us 180 degrees. So this is also a theorem in circle geometry. So this is a theorem that says the opposite angle in a cyclic quadrilateral equals to 180 degrees. I know what is cyclic quadrilateral. This circle is touching 4 points. That is C, E, you can see it now, C, E, B, D. So these are the 4 points. I know that, and any four-sided shape is called a quadrilateral. And this quadrilateral, they are inside this circle. So that's what made it a cyclic quadrilateral. So the student, they will just be imagining, looking at what you are doing. You say, what do you observe now? So the opposite angle of cyclic quadrilateral, when you add them up, it will give us 180 degrees. It's also a theorem. So from here, you are doing manipulations, doing some exploring, changing some things. You can even try something else. Just watch. If I move this C, let it be on a straight line with B, such that this angle becomes 180 degrees, the angle at the center, just watch. So this is 180. Let me see if I can move it gently. Let me use my mouse and control. Okay, yes, I've achieved it. You can see now that I have 180 degrees here. What do you observe at this circumference? You can see this is 90 degrees. This is also another theorem. You can see in less than 10, 15 minutes, you can demonstrate this theorem to the students. They are watching. From there, you see their critical thinking skill is being achieved. They are thinking, they are observing changes you are doing, that when the line through B and C, that is that major origin I started with B and C, when they cross it through the center, this is now a diameter of the circle, giving us angle of 180 degrees at the center. The angle at the circumference will become 90, which is the same first theorem that says angle at center is twice the one at the circumference. So whenever the circle comes as a semicircle and you see an angle from the diameter C and B, the angle at the circumference is going to be 90 degrees. And these children can exploit this and they can actually work with it. One beauty with GeoGebra, all these things you see me doing, after doing this in my class, introducing this to my students, just come to this place, you can see share. As you click on this share, a link will be generated. Then send the link to your student. They can go home and explore it. The same thing you are doing in class, they can do the same thing at home. That's one advantage it has. Children will begin to think on their own. They begin to explore. So those traditional teaching style begin to leave their mind. Even the teacher will be at peace because when they come, the next class, you see them. Let's take, for example, your first, let's say Monday lesson is circle geometry, the topic. You use the first lesson on Monday to do all this explanation. The student explore, ask questions. You generate this link by clicking here, share this link with the student. They all go home and exploit this. You will see when they come in the next class, everybody will start sharing their experiences, what they observe. Because everybody have his own way of thinking, his own understanding, his own way of exploring. So from there, the teacher will even see that the lesson will be easy. By the time you go forward to bring questions from any examination, you see the children answering easily. Some of them will even want to use this tool to answer the question. They want to practicalize it and see if truly is correct. So with this, those abstract thinking will leave their mind. They want to play with this app. They want to use it more so that they can learn better. All right, let's go back to the slide. All these are just little tips you can get from GeoGebra. All right, so that is one beauty of GeoGebra. I just demonstrated only geometry. There are so many you can do from here. Let's move on. I think we can see the slide now. Hello, are we there?
Yes, we can. Yes, we can see the
All right.
slide.
Now, this is another one. We say, why use GeoGebra in classroom? Even without explaining this, I've done about 2 already. Now you can see makes abstract concept visible. I say this is one beauty. And I've tried to do that with those 2 outlets from the latitude and longitude and what I just did in circle geometry. That encourages exploration and discovery. Even the teacher, you will learn more from this. There are some arguments that may come up with this. You can solve the issues. Then support interactive teaching. Your students, they want to learn. You see you asking questions, critical thinking question will be going on in class. You will be pausing because you are doing the simulation yourself. You are doing the analysis yourself. It's not that you are playing a video. So those are some of the gaps we have in videos. You see children seeing it themselves, telling you to hold on. Some of them may want to do it. Maybe there's something they observe. They say, excuse me, sir, try this, move this back. They just want to explore, which is very good for our students. You can see increases student engagement, very important. This is very, very important. Then provide immediate feedback. So as you are doing it, children are giving you their feedback, their understanding. Even when you put example in the class to solve and you use some of these tools to teach, your children will always have immediate feedback. They may even want to argue some of the results you got, some of the answers, and with this kind of tools, you can prove it for them, and you see your work will be much easier. Let me click on this link, and I hope it opens fast, because I've already selected some few applets we can use to get this concept very well. Okay, yes, this one is coming up. I hope we can all see this as it's coming up.
Yeah, we can see it. We can. Thank you.
All right. Now, looking at this, you can see this is a cone. This is a cone. This is another applet from GeoGebra software. Maybe one of these days, we'll just do GeoGebra tools as a lesson, because as a mathematics teacher, it's good you know how to use these tools. Because some of these applets, I designed them myself because I'm used to the tools. Some of them, I got it from the GeoGebra website. And one beauty about GeoGebra website, when you get the applet, if you come to this place, you click on this, you can see this construction protocol. With this construction protocol, I will see all the steps, the producer now or the manufacturer of this applet. I will see everything it did here. If I click on this, everything will appear here. I can follow it. I can design this thing if I like. But most times when the applet give you what you want, you don't need to change it. But there are some applets that may not achieve my objectives. So I will manipulate it my own way by coming to the construction protocol, see some things, I may change some things there, or I can go to the algebra views. Then from there, I can do some manipulation. But let's see this. This applet, I got it from the GeoGebra Classic website, and I did some few changes on it to suit my objective. This applet comes from when I was teaching in class some times ago. A child was confused about how can you turn a cone to a sector. That was what generated this applet. You know, sometimes one beauty of GeoGebra, it will help you to eliminate this prototype production of instructional material. Because if you want to produce a live cone, maybe getting a cardboard, cutting it, you need to buy these materials. And if you want to make it much okay for the student, you need to buy something that is of quality, something that will not tear anyhow in class. When you are using it, it will be strong. And the disadvantage now, you cannot manipulate it. Because when you do it in a way and the China says, what if we increase it? What will happen? All those kind of dynamic manipulation, you may not be able to do it. And that is one thing GeoGebra has brought to the table. Now, this is a cone. I want to open this cone and cut it, because it's a common question in our external exam, WAEC exam. Because sometimes they will tell a child to look for the radius of the base of a cone, when the cone is being cut and turned into a sector. Some information will be given and the child may be confused. Some of them will just memorize formulas and at the end they may even forget it in the example. But with tool like this, they can understand, go home, you can share it, as I said the other time, you can share it from here, give them the link. They can go home and manipulate it themselves, get it in their own understanding and improve themselves. Now, you see this place, I can change the height. You can see as I'm clicking on it, the height is increasing. I can change the radius, you can see. Then this is the net. This is the important part of it. Now, if I move this slide where you see this net, you see I'm opening the cone now. So that is the first thing you are telling your student, that a cone have two surfaces. You have the circular surface, which I've opened now, and you have the curved surface. They can see the body that is a curve. Now, this circular surface, if I open it out, it has a radius, and we call it small letter r. Now, let's keep sliding this net. As I keep sliding, you can see this arrow is cutting this cone now. So I'm cutting it. When I cut it, then I will open it wide. Just watch the way it will open. Immediately I open it, you see the shape that is being formed. This is a sector. Imagine showing a student this in class. Some of them will say, "Sir, pause. Can you go back? Let's see." You are helping their critical thinking skill. You want them to observe something. It's okay, let's go back. Let's close it back. I've closed the sector. A cone has been formed. I've sealed it up. Let me cover it. See? Let me stop the animation. I want to do it gradually. Now I move again. I open it. I cut it. I open it. A sector is being formed. Now, question will start generating from here. What do you observe now? By opening this sector, if you look at this big arc that comes from this end, round like this arc from this point to this point, if you observe it very well, let's close it. You will see that it's equal to something. Let's close it. Let's close. Okay. Let me close it. Okay. Now, as I open this circle, as I cut, before I open, I want you to watch something. Look at this circle of the base of the cone. As I begin to open it, you see it's getting wider. It's getting wider. It's the one that becomes wider and form this arc. And now remember, this arc is the length of the arc of this sector. Now from here, something has been generated. The length of this arc is equal to the length of this circle. So that is one formula. The student don't need to memorize this because they have seen how you open the cone, how you cut it and open it wide, how this arc, how it's being equal to this circle. So all they just need to do is to use the length of an arc. Let me see if I can get a pen. Okay. If they use the length of an arc, which is theta over 360 now. So theta over 360. I hope you can see my pen as I'm writing.
Yes, we can.
Hello,
we
can we see my pen? Okay.
Yes, we can see your pen, sure.
Now, another thing again, before I put the radius, if you observe, you will see that this is the radius of the sector. See, this is the center of the sector. This is the radius to this point where the arc begins. Now, this radius is equal to this slant height. That's why they made it 2, so that you'll be doing comparison. And that is why the color here is blue, why the circle is yellow. Now, you can see that this slant height is this place here, and that is this slant height. So this slant height, you can use any letter to represent it. Let me use L. Let's say small letter L. So that is L. So this is the length of an arc. So the length of this arc, getting this angle at the center, this angle here, which is the theta. So all these things will be given in the question, which is this theta. Is this theta over 360 multiplied by 2 pi L. So it's equals to, this is equals to the length of this circle, which is circumference of the circle, and that is 2 pi r, because the radius of this circle is small letter r. That is this 2 pi r. So that is this. Now, looking at this, a child don't need to memorize the formula now, because looking at both sides, you can see that 2 pi is common on both sides. It can cancel out like this. So a formula has been generated with the relationship between radius of circle, like base circle of cone, equals to theta, which is the angle at the center of the sector, divided by 360 times L. So this is a formula. And most exams usually ask this question of the base of the cone, if a cone is being opened. So with things like this, children will not memorize formulas. They'll begin to have understanding. Sharing this link with them, this applet link, they will understand some basic things very well. And manipulating it on their own way will be easier for them. They can still increase this radius. They are watching the way it's changing. They can reduce it. You can still change this height. See, they are watching it. So all these are some beauty of GeoGebra they can do, and it's helpful. So with this, I've generated a formula for relationship between the radius of a circle and length of an arc. And with this, you can do some calculation. And if you keep on going, you will see that this this curved surface of this sector is equal to this curved surface of this cone. Another formula can be generated from here. So the length, the area of sector, if I put the formula, it will be equals to curved surface area of a cone. You can see how the formulas are being generated. But if you are using traditional way, you can't manipulate these things like this. You can do a sketch on the board, but very few may understand you. Some of them will say, what is this man doing? Where is the shape? Because you are not touching these things, you are not rolling it around, you are not manipulating it, and they don't have opportunity to exploit it. So by doing this, you see critical thinking of the student will increase more and they will learn better. All right, let's close this and move on. So that is why you need to know how to use GeoGebra in your classroom. So you can see, I just use that applet to describe these few points I have here. Let's move on. Now, I have few demonstrations I want to do, just about 3 of them. Before I close this session. Okay, now, this is demonstration 1. I have linear function. And this is what I want to explore. I want to express. I'll start from scratch. So that I want to observe changes in slope and intercept and learning coordinate geometry. In coordinate geometry, when you are dealing with an equation of a straight line, the gradient, the y-intercept, some of this, especially this topic, was actually difficult when we were in school then. But you see our teachers just solving, generating formulas. Somebody is just confused. How did this man get this formula? We just memorize. We see questions, some confusing question may come in exam. We don't even know what we are doing, but we just, if we solve and get it good, if we miss it, we'll just be looking. We don't even know why we miss it. Or even sometimes we get the answer, we don't even know why. But using a tool like GeoGebra, you can do some manipulation. So now let me show you something on this demonstration. Let's go there. Hope it opens fast. Let me just go and search for it in my app again. This one may take time. Okay. Okay. All right. I think we can see the GeoGebra coming up now. Okay, now you are teaching linear graph or linear function, or you are teaching a straight line coordinate geometry with your students. Now, this is basic GeoGebra tool or the applet when it comes up. This is how it comes up. Now, remember, I want to demonstrate something on y equals to mx plus c, which is general equation of a straight line. Okay. Now, the first thing to do, I need to create sliders. I need slider for m, and I need slider for c. because those are the things I'll be manipulating. Now, if I click on this, you see the slider. Just click on the slider. She's telling you to give minimum value. Let me just do 5 for minimum, 5 for maximum because of time. Let me make the increment 0.1. So just type 0.1. So it's a number slider. We are not working with angle. Okay. So one thing, let me name it. Let me name this slider. Just rename it. Let me name it M so that it represents my M. All right. Let me take it to 0. Just click and drag it. Go to 0. You can actually do this in your class when you are introducing this topic to the student so that they will know what you are doing when you start solving gradient of a straight line, equation of a straight line, and they will follow you well because they have visualized it. They have also gone home to play around with this applet and explore it more. Okay, let me create another slider. Okay, so this slider now, I want to call it C. Just click on the slider, click on this graph. So let's also make it -5 and 5. Let's say this is 0.1. You can increase the number even to 1,000, whatever number you like. But because of time, I'm just making it short. So let me change the name here. Let me call it C. So small letter C. Okay. So I have my 2 sliders. Don't forget to always click on move so that you can click and drag whatever you are doing. All right. Now, this is my slider. This is my graph. Just come to this input place under your algebra view. As you click on it, just type y equals to, just type from your keyboard or you use the keyboard of GeoGebra here. Y is equals to mx. So immediately I type y equals to mx, something has appeared here, but you may not see it because everything, this one is 0. But let me put C. You will see that this horizontal line will move at 1 because what this C is the y-intercept. Immediately I put plus C. You see, it has come to display. As you are typing, it's appearing on the graphics view and the graphical view here. So we are through with the typing. Just click on enter. Now this is the line. So let's start the exploring now. Remember, C is my y-intercept. This is the intercept. Then this is my gradient. Now you know what gradient means. Gradient is the slope. Is the change in y. How is this line changing between y2 and y1 to x2 and x1? No, that is the slope or the gradient. Yes. Now, if let me make it positive gradient. As I move it positive side, you see what is happening. Just be watching the graph as the slider is moving. As I'm moving it gradually, you see how the graph is changing in slope. And another thing again, you see that this gradient is a positive gradient. You can see that the graph rises from your left on this side down to your right here. So you keep going, see, you keep going, see how it's moving. Then the intercept is 1, which is point C. If you move this, you see the intercept is changing. Let me bring this slider down. When the intercept is 2.1, you can see this is 2. As I keep sliding this intercept, you see the graph is moving up. So when you are doing this in your class, you see your student watching. Some of them will start observing. You are helping their critical thinking skill. You are helping them to think critically now. They are watching. You are just doing it around. Later, you ask some questions. Now, let me move this to, let's say, -2, see, which is the y-intercept, -2. Then let's move this. Let me take it to the highest, which is 5. You can see. So this is the gradient. Now, by doing this, your student sees the way this graph turn around. You can now ask them, what if this gradient is negative? What do you think will happen to this graph? Because there is a tool here, you don't move it here. You ask them, what if gradient is negative? How do you think this graph will look like? Is it going to be on this direction or is it going to be on this other direction? How do you think the graph will look like? So the student will start thinking, saying their own view. From there, you say, okay, let's move it and let's see. So as I'm approaching negative, you see what is happening to the graph. It's moving. Immediately I get to 0, you see gradient is now 0. There's no more slope. You are not climbing anything like hill again. So it's now on horizontal ground. This is a flat level ground. So the slope is 0 and the graph is straight. And the intercept C remains -2. So with this, the student begin to get something. Then you show them the equation here. Y is equals to 0x, which is y is equals to -2. There's no gradient in this line. So with something like this, your children, they are thinking well, they begin to get used to the topic because you're introducing the topic. That's one beauty of GeoGebra. You help them to introduce the concept very well before you start your calculation in class. Especially the first day you introduce a topic. It's good you use GeoGebra on that day. Explore it, let them explore it, do some analysis based on your objective you want to achieve on that lesson. Do things like this, children will begin to get it right and they move on well. If you move this one, C, anywhere you move C to, as long as the gradient is 0, you see how the line keeps moving along this side, just like this. Now, if I move to negative, you see the graph have moved to this other direction. That means when the gradient is negative, the graph will slope from your top left here down to your right here. So sometimes questions comes like this, especially OBJ question, they will say, which of the following equation represents also graph? Or they can give you a graph that the graph above, what is the equation of the graph above? Some students may be confused. All they just need to know is to know this y equals to ms plus c, and this intercept, they should know that y-intercept is where the graph touches the y-axis, that is this c. Then the gradient is the slope between 2 points on this straight line. And that is what decides how this graph will go. If the slope is going to be high, see, or is going to be low, depending on what you want to achieve. Then there are other ways you can see the slope. You can see there are other tools here. You can get the slope. Let me come here. Okay, no, slope is on this side. You can see the slope here. So if you click on this slope, you click on the line, see the slope will appear on this place, telling you that you are picking 2 points, this point and this point. You subtract them. From there, you can start your calculation in class. Student will even start checking, excuse me, sir, why not pick another 2 points? Let's see if we get this slope of negative 0.8. You can pick this point and pick another point somewhere here. They will do the subtraction, they will get the same results. Now they are exploring. They want to see if what you are saying is correct. They can tell you, okay, let's change the slope to positive side. So they are watching. You are just doing this manipulation. That is why we call it a dynamic software. You are just manipulating it. So they are watching, they are exploring, they are asking questions. And by doing this, you are helping them to think critically. So that is one way you can use GeoGebra for linear graph. There are so many things I can actually do here. If you are creating points, I can create points. I can do slope plot. There are so many things. I can create different points when you have tables and you are joining them with points. I can do so many things. And now that I've clicked this point cannot leave this line. They are on this line. They are on this line. I can join them if I like. You can type slope plots here. If you just type slow, you see, as you type the 3 letter, you see slow plot. You can put the function, so I can actually do so much. But let's leave that because of time. As I said, we just need to have another section sometime from now, so that we can learn some of these tools to help teachers to know how to use it more and better. Yes, so let's close this. Okay. So that is first demonstration. Another demonstration I would like us to see is something on quadratic function. You know, this is another important topic in mathematics. You can still do the same thing. You can create sliders for A, B, and C. You can vary the sliders. Your quadratic graph will appear. Students will begin to see this focus. They will begin to see how the shape is changing. Like when you are teaching calculus, you are doing minimum and maximum points. So many things the student can do. They are watching the direction, how it's changing, how the graph achieves its maximum point or minimum point. So all these kind of questions will help them. Even getting the gradient on a curve, just like that. Let me just do something quick here. Okay, this one may not work. Let me go back to, let me set again. Yeah. Okay, so I hope we are following. Hello, are we there?
Yes, sir.
Yes, we
Hello.
are
We are
here.
following you.
Yes, we
All
are.
right.
Yes,
I'm
right
just,
on.
I'm just watching time so that we can go on time. Okay, so this is the interface again. Let's create 3 sliders very fast. This thing is blocking my view. Let me pull it down. Let me pull it down so that I can see it. Okay. Now, if I do my slider very fast, I need the coefficient of that is the constant now of the quadratic function. So let's get this is already A. Let me just leave it like this. Let's leave the increment at 0.1. So let me get for B. So this is also B. Let's leave the increment at 0.1. So let's create another one, C. Let's leave it at 0.1. Okay. So these are my 3 functions. So all I need is just to type my quadratic equation here. If I just type my y equals to ax, if I need power, I can use this as squared. You can see as I'm typing it, you can see it's generating the equation here. That is the line is generating it here. So this is a line of y equals to ax squared. Remember, the a is 1 based on my slider. So let's keep going. So if I say plus bx, c is adjusting it here. If I now say plus c, so my quadratic function has been plotted now. You can see it. You can click on the screen and drag around to view more. So this is the function. Now you can start moving this slider for this student to see this. Now, remember what just happened now. This curve, the minimum point, see, it's not even touching the x-axis. So when you are doing some things in class, like you want to know if a quadratic equation have a root or not. So this is a good question to give them for equation that don't have roots. So there's no way they can solve this quadratic equation to have root because some of them we are. So why? Why can't we have roots? Why? You know those kind of questions. And you are solving in class, you are telling them there's no method. Sometimes the students they want to see this thing. So by showing them this, you tell them that quadratic equation is actually a line. It's actually a line that is of this parabola curve. You are trying to tell them that this value of C, you can see this C is the y-intercept. They are seeing it here that C is 1. If you move this C, they are seeing how C is moving along the y-axis. It begins to make sense. It's helping their visual skill now. They are seeing, they say, okay, you say, yes, this is the y-intercept. So anywhere C moves, you see the graphs keep going up. So they'll begin to reason that, okay, so that is that. That is it. Now, as they view this, you say, okay, let's leave it down so that this graph will have roots. Now you can see that the curve have passed through these 2 points on the x-axis, which is -2 and 1. So this is the root of the equation. Okay. Okay. So if you move B, as you're moving B, you see how the graph is moving. B is tending towards negative. You see how it's going. You see, all these things will help their visual skill and how they can exploit. You can see. Then if you look at A, as I'm moving A, as A is going towards negative, you see the graph is getting wider. You can change the scale if they cannot see how wide the graph is. Just click on this move. So click on it, just slide down and slide down. Now you are changing the scale. This is 2 unit, this is 5. You can change it, you can put it on the edge, just click and drag in. You can see it, I can make it 5, 5. So that as you move this slider, anywhere it moves, so you can see it clearly. You can keep changing the scale. So as you're moving this, they are watching, they are exploring, they are trying to interact, asking questions. Then let's watch what will happen as A becomes negative. Just watch. Now, when A is 0, this is a straight line. And when they look at the equation, this is equation of a straight line. That means the gradient is now 2.7. 2.7 is now the gradient. So you can see there's a straight line. Immediately A turns to negative. You see the graph have turned to maximum point. So with this, they begin to get something that, oh, for us to achieve maximum point in a quadratic curve, that means A need to be a negative value. Because those are some things students really don't understand. When you tell them to find the maximum or the minimum, they will be saying, how do I know if this is maximum or minimum? How do I know the maximum or minimum? First thing, they don't know that they need to check A. So with this kind of applet, they will know that when A is negative, they are going to achieve maximum because the graph is going to turn up. Then when A is positive, they are going to get negative minimum. You see, it's going down. When A is positive, it's minimum. Then when A is negative, it's maximum. So with things like this, they are viewing it, they are manipulating it, and they are seeing it. See how I'm just moving it around. You can do other things. You can do slow plots. You can manipulate this. We just depend on your objective. You are the teacher. You know what you want to teach. You can actually do more. If you can't get if you don't know how to use the tools, you can go to the GeoGebra Classic website, sign in there. It's free online. As you sign in with them, you can get applets. You can download free, use it anytime you like in your class. But you need to be used to the tools so that you can do some manipulation as you are working in class with your student. All right, let's go and round up our work. So that is that. So this is other one. Let me just demonstrate this very fast. This one is on triangles. You can do 3D shapes, so many things in this GeoGebra. Let me just explain this fast. Now let's delete some of these things. Let me delete this. Okay. Okay, let me pick this triangle. So you can create a regular polygon. That is an equilateral triangle. You just create any triangle, irregular triangle. Let me create this. Remember, this polygon. I can use it to create triangle or any shape. So we always use polygon for plane shapes. So if I let me create triangle, something like this. So you are teaching your student triangle in class. You can do so many things here. You want to tell them about the area of the triangle. This is the triangle, this is the height. You can create something like this. I can do a perpendicular. Let's get a perpendicular from this point A to this baseline. You can see the perpendicular line. I can create a point. Let me get intersecting point from this line to touch this. So this is my intersecting point. Can get my segment, join A to this point. Then I can hide my perpendicular line. Just come here, hide object. So this is A. You can see what is happening. As long as this A, I move it anywhere, you can see that the 90-degree line still remains the same. So that is one. So wherever this perpendicular line, wherever this A goes to, you can see that this height remains 90 degrees. So those are some things you can do in your triangle class, telling them that this height is very, very important. Let me create this perpendicular in another way. Let me do something different. Let me get a line so that I can adjust it outside the triangle. Okay. Okay. Okay, I want it something like this. Yeah. Okay. Let me create another perpendicular from here to this line. Okay. All right. So now, so I want something like that. I want it to go outside the triangle. Then let's get a point. Let me get this point here. You can actually hide what you don't need just because of time. I'm just rushing. You can hide what you don't need. Let me remove this. Let's undo it. Okay, I need a segment first before I remove that. Okay. Okay. So let's hide this. Now, So as long as, let me generate the area of this triangle. Let's get area. So this is area. Let's just click on it. So this is area of the triangle. The area is 75. You can, as you are teaching area of a triangle, you can let your student know that the height is very important. The height of a triangle must be 90 degrees to the base. So if the base starts from B to C, which is half base times height, the height must be the length from the top of this triangle here, and from this apex point, must be 90 degrees to this very base. And anywhere this A goes to, just watch, wherever I move this A to, this 75 will not change as long as I maintain this height. Let me be moving this gradually. See, as long as A is moving along this line, see, area 75 will never change. You can see the way the height is moving, 75 will never change because the height remains 90 degrees to the base. If you want to put the 90 degrees symbol, you can put it by clicking on these 3 points, A, G, and C. You can see the symbol of 90 degrees there. So as long as A is moving, the triangle remains 75. So just like that. So anywhere you move it to, it remains the same. So let me move this, just click on it, come here, change it to 180 so that we show 90. You can see it. So this is some things you can do in class to help the student critical thinking, help their visual understanding. You can see how it keeps going and the 90 remains the same. You can hide any point you don't need. So because of time, that's why I'm just showing you this. You can do sum of angles in a triangle equals to 180 degrees. You can show them. You can do so much. If you want to show them maybe solid shape, just come to this place. When you are teaching in class, just click on 3D. You can see the 3D view has appeared. Now let's click our triangle. Okay, let me drag. Okay, I need to get the, let me get my axis and know where the center is. Let me get my center axis. Okay, let me get my axis. Okay, so I need my center. Okay, so let me put this at the center. I just want us to see the triangle. Let me reduce it. Okay, let's reduce it. So if you observe, as I'm changing the triangle on this 2D side, it's appearing on this 3D side. See, I can click on the 3D side and move it. So all these are some manipulations you can do in your class. That's why we call it dynamic software. As I'm moving the triangle, you see it's moving on this side. I can remove the axis of this 3D side. Just click on, right click and remove the axis. So you can leave the base. You can leave the base plane, which is the default plane. You can leave it, let it serve like your foundation. You can see it. You can click, as you click on this 3D side, if you observe, you see all these icons have changed to 3D. When you click on the 2D side, they have all changed to 2D. So if I want to do something like maybe solid shape, maybe prism, cuboid, and pyramid, and whatever shape I want to do. So just click on the 3D side. You can see them here. This is pyramid, this is prism. You can extrude, you can extrude to pyramid, extrude to prism, whatever you want to do, cylinder and the rest. Let me just do something you can show your student why this GeoGebra is very important. Let's just take a simple prism. Let me make it dynamic. Let me use one of these sliders. Let me use slider A, for example. So as I come to 3D view, as I click on this, let me extrude to prism. As I click on this, see, it's telling me to select the polygon or the circle that I want to extrude. This place is very important. So as I click on this, it's telling me to put the altitude. Where will my prism rise up to? So I want to use this slider A. Let me just type A. Okay. If you observe, it moves down because slider A is negative 0.2. So as I move it up, if you observe, as I'm moving this slider, my prism is moving. See, I can move this leg now, let's say this vertex of this prism, as I'm moving it, see it's changing here. So all these are some things you can do to help your children visualize these things. If they want to learn surface area, they can see it here. You can click on this, you can rotate it if you like. Okay, you can see rotate, you can rotate it if you like. You can reduce the speed, you can make it turn negative side or positive side. See, all these things help the children visualize what you are teaching, help them remember formula. You don't need to memorize. You are teaching surface area of this. They can easily see it and learn better instead of memorizing formulas. And you may not have the time to construct this thing, because that is one thing GeoGebra have tried to do to eliminate time for production, prototype productions, and the rest, to eliminate those things, to make it clear, and you will get the same result as if you are working in real life situations. So that is that. If I want to do something like the net, just come to display. You see net here. As you click on the net, just click on it. You see the net has appeared, and a new slider has been generated for the net. So you click on it, you can see, I can turn it like this. You can see it. You can rise it up. This is the new slider for the net. I can cover it. So with this, they are seeing the surface areas. They are seeing other things. There are so many things we can do. I can type it and manipulate it gently, depending on where I want to cut it from. So that is why you need to know these tools very, very well. So I think that is all for now. Let's stop here. There are so many things you can actually do. There are so many things. But I want us to know that GeoGebra is a good tool for mathematics teachers, to help the teachers to grow well, to help you in your interaction in class. See, interactive classroom, it will help. Just, just take note of that. To help you well, let me just go through this slide. You can do tools like this. You can see transformation. This is another topic that is somewhat confusing for teachers and students, most especially students. Some teachers find it difficult to manipulate these tools for students to get, but using GeoGebra, it will be so easy for teachers to explain and students to understand. If you, let me just do something quick here. If you have a triangle, let me just make a small triangle here. You see this place. You see, these are the transformation tool. You can see, you can reflect, which is mirror now. You can reflect about a line, about a point, about a circle. You can do rotation. You can do translation. You can enlarge. Anything you want to do. Let me close my 3D view so that we can see this. But if I want to work on this, let me do something on enlargement. I'll use one of these sliders for enlargement. Let me use slider B for enlargement. If I click on enlarge, remember, when you want to enlarge, take note of what is happening. You say you should select object, then you need a center point when you are enlarging. Then you need the factor. So the factor, I will use this B as my factor. So let me create a point that I will use for my enlargement point. Let me just put this point. Let's take point Z here. Now, if I click on enlarge, tell me to select the object. So this is the object. I want it to enlarge about this point. Then my factor should be B. As I type B and OK, you see it has been enlarged. So this will help your student to understand transformation. As I move this slider, you see the way it's being enlarged. As I move the slider to 1, this is a scale factor of 1, so 1 to 1. So everything is okay. As I move this scale factor to 1.5, you see, is bigger now. So with this, when you see question on transformation on enlargement, with this kind of tool, the children will begin to get it right because they are viewing how the shape is being enlarged. You see the way the triangle is being enlarged using this scale factor. So you can create the distance from this U to U prime. You can measure it. I can create the distance, use my distance tool here to get the length. You can see distance. I can use it to get the length. See, which is 10.07. I can do this. You can do it to another length from here to here. Do your ratio. you know the calculation how we do a scale factor ratio, you are doing comparison. The bigger side to the smaller side, I can measure this side, divide by this side, look at the two parallel sides. So all these things, they are easy using GeoGebra and it makes the children understand better. Even if it's negative scale factor, let me take the slider to negative. You can see the negative scale factor. Immediately you get to 0, nothing is appearing. Then when it crosses to negative, see what is happening. A negative scale factor now looks like a reflection. Now looks like a reflection of this, but in the negative side. You can see how it's being changing. It's enlarging, but in the negative side. So all these things help children understanding so that when they see question in class, they will not be confused, but they must have explored it, getting the link from this shared. They must have gone home and tried the same thing you are doing in class. So you explain for them, they go home and practice. It will help them to learn better. So that is that. So that is that. I believe we enjoy this section. These are some benefits for teachers and students, and just go through it. So these are some tips how you can integrate into your classroom, how you can integrate technology into your classroom, how you start. These are just some few steps we just put down here. And this is where you can get GeoGebra. Just go to this website, register with them. It's free online. They will send you some link into your email. From there, you confirm and you start exploring. You can go to YouTube, get some videos. You can register. As you register with GeoGebra, you can enter the GeoGebra classroom activities. From there, you see applets and the rest. You can even join GeoGebra community and forums. You can see so many things there to help you to learn. As you use it, you understand it better. So that is that. So in conclusion, GeoGebra can help you transform mathematics learning from passive memorization to active exploration. Then take note, when we talk of technology, we are not saying the traditional way is totally bad. It's still okay, but GeoGebra, tools like GeoGebra in technology will allow the student to explore. They will explore more compared to the traditional way that they may not be able to explore more. They may not be able to do some dynamic manipulation of these things, and they may not be able to visualize some things very well. And it will help them to think mathematically in ways see that the traditional instruction may not be able to do or achieve. So that is all. Thank you for listening and following. Thank you for joining this session. So you are all welcome once again.
Yeah, thank you so much. Thank you very much for this amazing session. You may want to take a look at the comment section at the chats. We've been having fun there trying to really understand, and this is very good. I must say that you have a lot of amazing feedback from the in the chat box. A lot of people, someone is practically happy because he said he's going to be is going to be exploring graph with his students, and it's a good thing because right now he knows what to do. He knows that he can use GeoGebra to do this magic in the classroom. I'm not a math person, sincerely, but I really wish I knew about the GeoGebra when I was in secondary school. But because I'm very sure that if I knew about this too, I would have gotten A1 in maths in my WIEC, and also looking at the fact that we started around 7, we started this class 7 on the dot, and right now we are looking at 8:28. That is an hour 28 minutes, and Light has been following this class from the beginning to now. That's interesting. I'm not that kind of person with maths, but this shows you that this is a very interesting tool and it's a very good one. Okay, so are you still there, Mr. Bamu? Would you want to answer some questions in the chat box? We can't see your screen anymore, so I don't know. We can't see you anymore. I don't know if it's light, if it's electricity issue, or if you're not there. So can you hear me?
Can hear you very
Ah,
well.
okay, okay. Thank you so much. I can't say thank you enough. Thank you so much for taking this time to really do this. I'm going to go through some questions. Somebody was really curious to know um So I'm going to start from the beginning. Somebody is curious to know how you were able to bring in the tools. You said something about the tools that you used. So you said that way, you said it's very interactive, but please, where are you importing the diagrams? I know you talked, it is something about construction. You showed us like a construction set. So I don't know if that is where you're bringing in the diagrams from, but it's something that you may want to really address. Then somebody's also asking if this is free. Yes, so Aurora, yes, it said it's free. It's free. And Danny wants to also know what your recommendation is. Are you recommending Classic 5 or are you recommending Classic 6? Um, yeah, thank you so much, Salome. You're recording for your colleagues who cannot join. I'm also going to be sharing Mr. Agbamu's YouTube channel. He has a YouTube channel where he has a lot of stuff on GeoGebra, so you can go there and watch it. Then someone is also asking that can GeoGebra assist in solving some math assignment topic given to learners? So a lot of people, some people here are not math teachers, they are parents of secondary school students, and this is something that I know comes in very handy for them. So you may want to direct them on how they can go about it. And I think the last question is okay. Is it a free tool and are there subscription for it? So would you want to quickly answer these questions while we round off? I'm going to be posting two things. Mr. Agbamu's LinkedIn channel. I want you to go and follow him on LinkedIn, please. Very important. And I also want you to go on YouTube, subscribe to his channel. He has a lot of amazing stuff where he was able to do tutorials on how to use GeoGebra effectively. Over to you, the answers to the questions.
Like the one for if you can solve an assignment for student, it cannot solve assignment for student. The way the tool is designed is for student to explore the topic, for the teacher to explore the topic and use it to teach in classroom. Because most of these AI tools, that's what students use these days. They just snap the assignment, put it into all these tools, it will just solve it. GeoGebra is not like that. It's something that you need to use it to learn, to start from the scratch, understand concepts. So that is one major aim because that concept is very important. We are not even looking at how to solve the math. We need to know how this, in short, where are you applying this thing? What is he actually talking about? Can I see it? There are other tools in GeoGebra. There are even some, we like call them plugins of GeoGebra we have, like Graphable Math, Smart Notebook. There are other things that you can actually combine GeoGebra to do, but they are not for solving assignment or classwork, just to use it to get this concept to teach children. Children can use the applet to learn and understand. By the time they understand the word, there's no question you want to ask them. There's no question they will not know what to do because the idea is already there. They are seeing math. They are not seeing one abstract thing that don't have meaning. When they see a question, it will give them meaning because they have explored it from so many angles. From there, they will know what to do and solve from there. So I think that is the main question. The other ones of if it's free, it's free. If you go to the site, as you register there, it's good to register first before you start in the site. When you go there, just register. Everything is free. It's free, just as I said from the beginning. A it's an applet that came from a math teacher in Australia. You have this zeal on making mathematics easy. So you make it free. He said you don't want any paid version. And if you see something GeoGebra is doing, it's even better than some paid app. So he made it free and with some collaboration with experts around the world. So they made it free. If you go to the GeoGebra site, you will see millions of applets. There are so many. Depend on what you want to teach, just type the topic. That is why as a teacher, you need to know how to use the tools. Because when you sign in, you get the applet. They may not be, that particular applet may not achieve your objective. So going to that construction protocol, you will see how the producer did it. From there, you can manipulate it, change some things your own way to suit your objectives. So that is that. So it's free. Just go and explore and learn more. Then enjoy your teaching. I think I've answered some of them. Is that all?
Yeah, so somebody's also asking where you got the diagrams from, and which one should they use? Is it Classic 5 or Classic 6?
Now, for me, I prefer Classic 6. Classic 6 is much easier to manipulate. The
Okay,
Classic
Classic
5 is,
6.
yeah, the
Okay.
Classic 6 is better. It's
Okay,
much better.
so Classic 6 is better. Okay. Where did you get the diagrams from? I don't know if I'm correct. I know there's a construction set on the platform. I think that was where you
As I
got
said,
it.
but when you open the GeoGebra app, that is the software, you just see
Okay.
something like you see something like graph. So most people, when they see it like that, even teachers, they will say, ah, what is this? Because it does not make any sense.
Mm-hmm.
But you as a teacher, you know what you want to teach, you know your objective, whatever topic you want to teach. As you open the app, from there you know what to start from. Depend on your objective. It just depends on that's why you need to take with these days of AI, it's even easy for a teacher to learn it. Because those diagrams, they are all there, they are all in the app. It's just for you to go there, explore, you will see there. It's just for you to know the tools. If you know the tools, then you know how to get the diagram. Then some of those diagrams, I got them from the GeoGebra and applet from the website. And some of them I manipulated them to my own taste because I know what I want to teach my students. I know what they are trying to achieve. Some of them, as I'm in class, a child can just ask, just like I was teaching in a day, a child asked me question about can a diamond be the same thing as a rhombus? See those kind of questions. We all know that diamond is a solid, rhombus is a plane shape, and I don't have a diamond in my physical hand to show the child. So the only way I can do it is to use something like GeoGebra. And if I start going online searching for diamond, all those time I may take time. I just open my applet, open the tools, compare. I started comparing plane, the physical and that is the flat face and the solid face. So I did something like that today, where I did a triangle on the 2D plane and the prism on the 3D. I started doing it for the child. So the child started seeing different. Diamond is actually a solid. Though. I did a pyramid, then the pyramid I did a four-sided pyramid, that is a rectangular pyramid. I did a square base pyramid. I made plain. I just the way I did it, for you know, a diamond has appeared. So the child was now comparing it. There's a way I turned it. It now looks like a rhombus. So the child begin to get it. Say, okay, it's just because they are trying to represent a diamond in a 2D plane. That's why they are calling it a rhombus. A diamond is not actually a rhombus. It's just the way you viewed it. So all these kind of things, it help a child to think more and help them to learn better. So the diagrams, they're already there in the tool. It's just for you to learn how to use the tool. You get the diagrams. Yeah.
Okay, thank you so much. Thank you very much. So you can also check the chat box. We have the LinkedIn profile link of Mr. Magbamus. Yeah, his LinkedIn link. You can check that. And also we have the YouTube channel. I would encourage you to subscribe. He has a lot of content when it comes to GeoGebra. He has amazing content that talks about tutorials on GeoGebra there. And you can also see the join our community of educators where we talk about tech tools. We are everything about how to use tech tools and how you can use tech tools effectively in your classroom. Is 30 minutes past 8 night in so many countries? Some people are joining from different parts of the world, and I know that some people are having a very distinct difference when it comes to the time zone. And I'm so happy and I'm so grateful that you're able to join us and you're part of this amazing session. I'm going to encourage you. Remember, I also talk about the fact that you need to also scale your profile on LinkedIn. So talk about this, talk about what you learned today, share and tag Mr. Gbamu also on your post. I'm very sure that if you tag him, he's going to be very happy to engage with your post to also talk about what you did. So I'm going to take in a quick snipe. So if you are willing to just turn on your camera, I'm going to really appreciate that. Just a quick snipe to also share and tell people that this is what we did and this is where we're going, and also the exciting things that we learned today. So if you can just turn on your camera And I'm just going to take a quick shot, a quick virtual photo, a virtual photograph. But let us know in the chat box what you think about today's session. How exciting was it for you? Is this something that you're going to use yourself as a teacher, or maybe even as a parent? You have a teenager, a secondary school students that is going to use this tool. How are you going to use that? How do you want to use that? So this is something that you may also want to share. So let's quickly take a quick screenshot. And thank you so much everyone for trying to smile. I can see Hilaire smiling. Okay, I've done the first one. I'm gonna do the second one now. Yeah, so thank you. So there we go. Thank you so much, everyone, for being part of this. Please endeavor to follow to make sure you're joining or you're being part, you're engaging with Mr. Abamu's page on LinkedIn, follow him, then also go and subscribe to his YouTube channel too. So see you next time. We're going to have this again on a Thursday in June. We're looking at the second week of June. Something different, not GeoGebra, but something another tool that is also exciting and is going to help you to be a better teacher. Thank you so much for joining. Have a wonderful night rest and enjoy yourself. And thank you so much for making this as exciting as it is. Have a wonderful day, everyone. Bye. Thank you. Oh, the YouTube. Okay, let me share. Let me share that. Sorry. Thank you. Yes. Oh, thank you so much. Bye. Yes, I've reshared the YouTube link. Salome can check that. Thank you.